Welcome! In this video we are taking you to Europe to see where our natural hydraulic lime comes from.
Hi, I'm Brian Goya with BioLime, here at our natural hydraulic lime quarry in Emilia-Romagna in Italy. This quarry is a very interesting location because of the quality and type of limestone that exists in this region. This is a very pure and high quality argillaceous limestone.
But first of all, let's understand how limestone is formed in the process of mining this material. Millions of years ago, the shells and skeletons of many dead marine organisms have fallen to the seabed. These deposits have been compressed due to heat, pressure, and overall changes in the Earth's interior. Over time, this has created many more layers of sediment to form the rock we know today as limestone. When the oceans receded, the limestone came to the surface as sedimentary rock, which can now be mined.
It's important to note that limestone is constantly being created in our world's oceans and has always been since marine environments have existed. This makes limestone a life-cycled raw resource, which our built world can depend on today.
Behind me in our quarry is natural hydraulic lime in the mountains as geological strata of argillaceous limestone. What that machine is doing, the excavator, pulling the argillaceous natural stone from the mountain, dropping it directly inside the rock crusher. The rock crusher, as you can see, is eating, basically breaking the stone down. 3 stages, from heavy stone, to medium, to smaller, to where it eventually evolves to this. We're in the second stage of the NHL production process. The trucks have brought in the stone and have collected the stone for the second stage. And here is where we produce natural hydraulic lime. The excavators break that material down to the different rock sizes from 3 meters, 3 feet, 2 feet, 1 feet, to eventually to the specific type of size that we're after, which are basically on these piles right here. Once it's brought in from the quarry on the other side, the quarry's separating these different types of stones. And once they're processed down to the specific size we want, they're stored in this top area above the conveyor belts, which are going to feed it into the kiln. So this conveyor belt, which is just slowing down right now, takes this properly sized limestone. It's going up through that conveyor belt, dropping inside of these 3 kilns. Let's go over here and see what they're doing. This machine basically, through circular motion, fills up these pits 20 feet deep, full of rock. And this is the natural hydraulic limestone. That's argillaceous stone that we're burning. And you can see the very clay composition and the clay nature of this material. You can see a little bit of smoke coming from that one. You see the pile is much different already. It's starting to gain heat below. It's kind of like a super volcano, if you would. It'll just create it's almost like a vacuum. It'll basically suck down below, a turbine effect where complete convection takes place of the stone and the circular motion. But this completes the process of how each and every kiln is filled with the readily available limestone that's been quarried, sized, crushed down to size, and filled, and now is going through the firing process. This is a very ancient practice of burning the stone, something man's been doing for thousands of years, and is precisely how we do it here at our NHL plant. We take this wood from recycled pallets, from old pallets, and that is used to start the fire. The conveyor belts have fed that kiln right there because that's the next kiln that will be ready in 3 days. This one is ready at the moment. That will be ready tomorrow.
In the kiln, the stone is cooked entirely, burning off any impurities. It is a slow process lasting about 3 days. The limestone is converted into pure calcium hydroxide.
Crude natural hydraulic lime, calcium carbonate, being cooked at a very slow process. These pieces of wood are placed at the bottom of the kiln. And once that starts, rock is dropped on top of, and the stone, once that first layer of stone is able to achieve heat, its reaction through the entire rest of the stones are basically brought up and cooked and elevated and elevated higher and higher and higher until the entire silo filled with stone is cooked. This one is almost at that stage. Now the excavator is going to unload this kiln right now. Now the front loader is going to take it over to this area for hydration. What's happening here, complete hydration process. The blue tank behind me is water. It's blue for a reason. Calcium oxide is going through this process. Inside here, the water is being introduced to the CaO2 calcium hydroxide is occurring.
In this stage, the stone is brought into contact with pure water. When the water is added, an exothermic reaction takes place, where a large amount of heat is released as steam. This process converts the limestone into a powdered form of hydrated lime.
That readily available calcium hydroxide is going to stay there and remain for 3 days and allow itself to cool, naturally cool, and pulverize into itself. This is natural calcium hydroxide, water that is in the stone. You can see that some of it is powder, some still left are some bits of stone that need to be further crushed. And that's the next and final step before this becomes a readily available material as natural hydraulic lime. From here, to continue a pure and high quality product of all powder material, it is taken from the hydration area after 3 days and basically being dropped into here. You see this naturally falling down into itself. This is the pulverizer. That remaining material right here, those little bits that still have to be brought down. As you can see, it's a lot of powder here, but it's mixed with some other particulate that still needs to be smashed down. This is the final stage of pulverization into the grinder. The grinder keeps turning and turning and turning and pulverizing and pulverizing and pulverizing until it becomes a pure powder material. What rests in these chambers right here? These chambers, 1, 2, and 3, this is completely ready, purely pulverized, and this quality control process of pure powder natural hydraulic lime. From production, we finished the production process, took a sample of the natural hydraulic lime. We're going to take to the lab just to understand the compression test. We're basically going to find the proper threshold to meet the European standard. This is our protocol. Certified natural hydraulic lime 3.5. Let's take a walk inside the laboratory. This mold right here allows us to create this block. Okay? This block, what we're after is to achieve a megapascal rating of 4. This is just a sample that I took right from the chamber, but this is the dry one that's been sitting out. And what happens here is that this is basically going to measure the megapascal rating of this block.
As the machine is applying pressure to the sample, it has to achieve a strict protocol in order to be classified a certified natural hydraulic lime.
All the powdered material that's ready, what comes out of here, goes down through of this chute. This is the readily available material. What happens at this point is the bagging process will launch these bags from around the corner, bring that back around here, and basically remain us with a palletized product. And that completes the entire production process of BioLime natural hydraulic lime.